Hello everyone. Today I will be presenting my project Star Pointing via Servos that I made for EE102 Digital Systems Design. As you can see, I have made a contraption that consists of two servos which are located right here. And it is capable of pointing to a point in its upper hemisphere. I have loaded up the code already to control the servos manually to demonstrate that these indeed can move the way that I want them to, that I've demonstrated in my report as well. As we can see, the upper servo has the capability of rotating this around like that, and with the help of the bottom servo as well, they can have a combined area of scanning of a hemisphere. I will now show you the computations required for the angle transformation to get the desired angles, accounting for the axis tilt and time and direction, etc. So let me just head over to my whiteboard where I will do the calculations. Okay, so let's assume we have Earth with axis tilt equals 0 because the ROM gives us angles while the axis tilt equals 0. And let's assume this point right here is Ankara and we have an arbitrary point in space that is the star that we want to point to. So assuming that the distance between Earth and the star is infinitely large when compared to the radius of Earth, we can assume these distances as infinity. Therefore, this angle equal to 0. Using that, we can take this theta and use it to find the angle right here and make the necessary calculations from there. Since the sum of these four angles will equal 360 and we know this is 0, we know this angle due to the latitude of Ankara, we can determine the rotation from Ankara, which we will then use to drive our servos. And this star will rotate around the axis of the Earth according to the time as well. So let's assume this is the center of the rotation. Since that rotation is 360 degrees, which is 24 hours, we can conclude that an hour will equal to 15 degrees of rotation. And since a minute is 1/60th of an hour, we can conclude that a minute is 1/4 degrees. And these calculations need to be done by our circuit to make sure that we account for the time and the latitude which is required to be precise about our pointing to the star with the laser, which we mount on the end of the servo. I will also like to show you how to set the clock. So this button sets minutes, and this button sets hours, and the button in the middle resets the time. So you can set up the device whenever you're using. Finally, I would like to demonstrate my device working. So I will just enter an address from the bases using the switch and observe the servos turning to the desired angle. So as you can see, the servo is pointing that way right now, and if I change the time manually by the buttons I have allocated for that, we can observe the device rotating, and once it will reach the 180 degrees of the servo, it will rotate 180 degrees and the top part will rotate in the opposite direction. So again, let me demonstrate that. So it is pointing that way right now. So and now it's pointing this way. So the rotation is continuous, but since the servos cannot rotate 360 degrees, I have decided to solve that problem like this. And once I reset it again, it goes back to normal. I would also like to show that there is a compass here to orient the device, and the Arduino is again for providing the 5 volts. Here's a close-up of the contraption made up of the servos. I have put a bearing here to reduce the friction, since these servos are not that powerful. Okay, so in conclusion, we had hour in, minute in, cell and reset signals, all for the timekeeping module, which was used to set the time however we want. The clock input is self-explanatory. It is the clock signal, 100 megahertz clock signal for all the modules that requires a clock signal. The ROM again gives out the equivalent angles according to our address. It is a double 286 times 9-bit ROMs. And the angle transformer takes in the variables from the timekeeping module and the ROM, and it already has the latitude and the axis tilt inbuilt in it. While writing the code, set it as a constant, and after that it gives the error if the angles are not on the upper hemisphere, while the servos are able to point, and it gives out the angles to the servo drivers, which then turn our servos using a PWM signal, and the 7-segment display takes the value, which is hour and minutes concatenated to each other, and gives out the necessary anode and cathode signals in order to set the time on the 7-segment display, which is located on the basis tree.